Hello friends, there is one topic in derivatives called as implicit functions. It's a very important concept. There are a lot of questions which appear on implicit functions, either it be your state board exams or it be your JEE exams or your local CETs. You will definitely get one question based on implicit functions. So you need to understand implicit functions very thoroughly. Now, we have already been looking into something called as an explicit function. So whenever I talk about a function, there are two different types of functions, which is called as an explicit function and an implicit function. So we are going to today see the basic difference between these two functions, and then we will be looking into implicit functions into more detail. So friends, I welcome you all to this channel, Pankaj Lade. Let's begin with what an implicit function is and how do we differentiate it. Now, as I said, functions are going to be of two different types. One of them is called as an explicit function and the other one is called as an implicit function. So I can write like this: a function can be of two types. One is called as an explicit function and the other one is called as an implicit function. Now, what's the difference between them? Let's first of all try and understand what is a basic difference between an explicit function and an implicit function. Now, whatever functions you have derived so far, whenever you are writing y is equal to some function of x, so on the left hand side you get only one variable, and that variable is y, which is called as a dependent variable. I hope you all remember these things. Please watch my previous videos on derivatives to know these concepts in detail. So I have written y as a function of x. So y is called as an dependent variable and it might be any function of x. For instance, I can write like this: y is equal to x cube plus sine x plus e raised to, let's write, x square. So over here you can observe that on the right hand side there is an algebraic function, there is a trigonometric function, there is a composite function, isn't it? But all the functions contain only one variable, that is y. Every function is written only in terms of variable y. Every function is written in terms of variable x. So here x becomes your independent variable. X becomes your independent variable. So you can observe here that y is written in terms of x. So here y is called as an explicit function of x. So now you already know that whatever functions you have been learning so far are all of them are explicit functions. Now let's move on ahead and understand our today's concept, and it's called as an implicit function. So let's see what an implicit function is. Now I'm going to write one example. Whether you know this or you don't know this does not matter. If you do not know it, no worries, learn it at this moment, whatever I'm going to tell, and keep it in your mind. If you know it already, very good for you. Look at this. If I write an equation ax square plus 2hxy plus by square equal to 0. Now, if you have already learned something called as pair of lines, you will definitely recognize what this equation is. And if you have not learned pair of lines, absolutely no worries, no problems at all. Just understand what I'm writing over here. There is ax square plus 2hxy plus by square. So if you observe, there are two variables, x and y. And did you notice x and y are both indulging into the same equation? Are you getting it? They are both involved into the same equation. Now we can definitely represent y in terms of x. That is possible, we can do it, but that is very difficult. You can divide the entire equation first of all throughout by x, you get y upon x, you can substitute it as m, and then you get a quadratic equation that you have to solve, and there is a long process to get y in terms of x. Getting y in terms of x is possible in this equation, but it is not feasible. When I say possible, it means you can definitely get y in terms of x, but it is not feasible. It means the equation is not very easy, it's a very complicated equation. Hence here we will not try to get y as a function of x. You can observe x and y, both of them are indulging together into the same equation. Such kind of equations, such kind of functions are called as implicit function. When x and y are implied together with each other, they both appear in the equation at the same time, and when y cannot be explicitly expressed as a function of x, then my friends y is called as an implicit function of x. Now as I said, in this equation you can definitely get y in terms of x, but look at the next example that I'm going to write. So if I write like this, log of x plus y is equal to sine of x plus y. Now whatever you try to do, whatever mathematical equations you try to bring here, anything that you are going to try and do here, you will not get y as a function of x. That is simply not possible for such kind of equation, and there are many equations like this where you might not be able to get y as a function of x. So whenever x and y are indulging into each other into the same equation, they are implied into each other into the same equation, at that time you can call that function as an implicit function. Or you can more easily remember like this: whenever you are not able to isolate x and y, you cannot separate x and y, you cannot represent y as a function of x, then you can call y as an implicit function of x. There can be many other examples. Let's write one more. So if I write e raised to x plus y is equal to tan inverse of x upon y. So in this case also there is very less possibility of expressing y as a pure function of x, representing y only and only in terms of x. So that means here you can observe left hand side contains only y, right hand side contains many terms of x. So that is not possible in these equations. You might not be able to get a single isolated y on the left side and function of x on the right side. No y should interfere on the right hand side. Not even a single term of y should be present on the right hand side. Every single y should be present on the left side, only y, and on the right hand side there should be only x, terms of x I should better say. So whenever you are expressing y as a pure function of x, then it is called as an explicit function, and whenever we are not able to do this, then my friends we will call it as an implicit function. So that's a very simple concept. Now how do I differentiate an implicit function? Very simple technique it is. Just understand what I'm going to write now. Understand it very properly so that when you start solving the questions it becomes very easy for you. So understanding concept is very important. So make sure that you listen to this very properly now. Now whenever an implicit function is to be differentiated, that means there will be two variables, let us say x and y. There can be some other variables also, but most of the times there are the variables x and y, and they will be implied into each other into a single equation. What you should be doing? When you start differentiating, you know how to get the derivatives of all terms of x. If there is x cube, you will write the derivative as 3x square. If there is sin x, you will write the derivative as cos x. If there is log x, you will write the derivative as 1 upon x. But now my friends, whatever term of y you get, listen to this statement now very properly. whatever term of y you get, you will differentiate it exactly like x. For instance, if you see y square, you compare it with x square. So I'm just replacing y with x. So every term of y should be differentiated exactly same as a term of x. So when I say y square, I will compare it with x square. The derivative of x square is 2x. Therefore, the derivative of y square will also be 2y. Suppose if you have tan y, so you think about the derivative of tan x. So what's the derivative of tan x? It is sec square x. So that's why the derivative of tan y is going to be sec square y. So my friends, whatever term of y you see, you treat it like an x and you differentiate in the exact same manner as you are differentiating the terms of x. Now let's try and differentiate this. There is one big catch over here which I have not yet told you. I am going to tell you when I am going to start differentiating this equation. So I'm going to differentiate this equation. So let's differentiate. I'm going to call this as equation 1. So over here, if I start differentiating, look at this. I have ax square plus 2hxy plus by square equal to 0, and I am going to differentiate both sides with respect to x. So let's get the derivative. So as I said, there is no worries in differentiating the terms of x because we already know it. What is going to be a point of worry is the terms of y. So you differentiate the term of y as if they are terms of x only, isn't it? So look at the very first term. So if you observe, there is a first term which contains x, there is a second term which contains x and y attached with a plus sign, then is a third term by square. Remember, y is not a constant, y is a function of x. The only problem is we are not able to express that y as a function of x, isn't it? That's a difficult part for us. We are not able to differentiate y, we are not able to express y as a pure function of x. That is why we are introducing this concept called as an implicit function. So now the very first term, the second term, the third term, I am going to differentiate exactly like the terms of x. So differentiate both sides with respect to x. The first term is ax square. So think about like this. There is a d by dx here, d by dx, and you are differentiating ax square. A becomes a constant, so I write a, and the derivative of x square, you all know it is 2x, so I get 2x. Then plus 2 and h, both of them are constant. So keep on thinking that a d by dx is written every single time. I'm writing d by dx everywhere. So there is a d by dx here, and then 2h was a constant, it came outside. So d by dx and then a bracket. So I'll write it over here to make it more simpler for you to understand. D by dx of x into y. Now this is a very important point. Remember it very thoroughly that y is not a constant. Y is not a constant, my friends. It is a function of x. Y is a function of x. So now if x, you can observe, it is a term of x, and you know that y is also a term of x. So there is x, another one is also x. So this is product, isn't it? It is a u into v rule. So I need to make use of the u into v rule. So I will go to write a bracket over here. Let us put a bracket over here and then write, or better, I'll take it on the next step. So plus, let's write 2h, put up a bracket. So I'm going to differentiate x and y. So keep in mind that y is like x only. You will just treat y like an x. Whatever term of y you get, you treat it like an x only. So I write x first, then think y like an x. What is derivative of x? It is 1. So same way, what would be derivative of y? It will be 1, but you are differentiating with respect to x. Remember that when you are differentiating x with respect to x, the answer is 1. But when you are differentiating y with respect to x, a term of y is getting differentiated with respect to x, the answer will always contain dy by dx. That's a catch that you should always remember. Whenever you are differentiating any term of y, you differentiate it exactly like x, just add a dy by dx at the end. That's all you should be doing. Just add a dy by dx at the end. Actually, this concept is from composite functions. Make sure that you go and watch my other videos also. I have explained in too much detail what a composite function is and how do you differentiate it. So make sure that you like all the videos, watch them very carefully, subscribe to the channel. It's Pankaj Lade. Go and see all the videos. That is all I can tell you about composite functions at this moment. So I hope that you have already watched that video, you already know the concept of composite function. So whenever you are differentiating an implicit function, remember, an implicit function where you get a term of y should be treated like an x. Just add a dy by dx at the end. You just multiply the entire derivative with dy by dx at the end. So here I have got x, the first term, isn't it? X, the first term. Then there was y, and as I've said that y is like x only. The derivative of x is 1, so derivative of y is also 1, but it is a term of y, hence I will write dy by dx. Then dy by dx, then a plus sign because it is u into v rule, isn't it? First term as it is, derivative of second term. Now the second term as it is, so plus y as it is, and derivative of the first term which is x, and it is also getting differentiated with respect to x. So I'll write 1 here and you close the bracket. So that was the derivative of the second term. Let's move on to the third term. Remember, y is not a constant, it is a function of x. So think about y square as x square. So the last term is going to come plus b, because b is a constant, and derivative of y square. So y square is like x square. Derivative of x square is what? It is 2x. So derivative of y square is going to be what? 2y. But it is what? It is a term of y. So let's not forget to multiply finally with dy by dx. Just add that term dy by dx whenever you are differentiating a term of y. All the terms are over. It is equal to, on the right hand side, 0 is there. When you differentiate 0 with any particular variable, the answer is going to come 0. So now let's simplify this. Finally, we will simplify this step by step. Now what you should be doing in such kind of questions is get all terms of dy by dx on one side and all terms which do not contain dy by dx on the other side. Mark my words very properly. I said take all the terms which contain dy by dx on one side, collect all of them on one side, and all terms which do not have a dy by dx on the other side. So if you observe this 2ax, this 2ax, isn't it? That does not have dy by dx. I'm going to send it on the other hand side. Similarly, when you take this 2h and when you multiply it inside the bracket, when you multiply 2h inside the bracket, this term also will not have dy by dx. So these two terms I'm going to transfer on the other hand side. Both of them are positive terms. When they go on the right hand side, they will become negative. They will change their signs. So now what terms are left here? 2hx dy by dx. So 2hx dy by dx, 2by dy by dx. From these two terms, I can simply take out dy by dx common, and what terms will be left? In the first term, I'll be having 2hx, isn't it? The first term will have 2hx left over here, and in the second term, I'll be getting 2by, and from both the terms, I have taken dy by dx common, isn't it? Now, the two terms which are left, the two terms which did not have dy by dx, will be now transferred on the other hand side, and they are going to change their signs. So let's transfer the two terms on the other hand side. So that becomes minus 2ax and minus 2hy, minus 2hy. Now what you can do here is you can take out a 2 common from the left hand side and a minus 2 common from the right hand side. So my answer is finally going to look like this. So dy by dx becomes equal to this, called, students, transposition. We call it as transposition. I'm going to just leave dy by dx on one side, because what was my question? I need to find dy by dx. That's my question, isn't it? So I have to get dy by dx. Whatever other terms are present along with the dy by dx should be transferred on some other side. So they are multiplied over here. When I transfer it on the other hand side, this is called as transposition. So I take out a minus sign common. The 2 is also common. The 2 in the numerator, and when this term goes in the denominator, isn't it? It is multiplied over here. When it goes on the other hand side, it will get divided. So minus 2, and then I have ax plus hy gets divided by, so 2 is taken out common, and you get hx plus by. So this 2 and 2 gets cancelled, and your answer comes dy by dx is equal to minus of ax plus hy upon hx plus by. So that's how we get the derivatives of implicit function. Now this was just one example that I've taken. I'll take few more examples for you to understand this concept in more detail. So students, make sure that you are noting this down. Make sure that you are writing down these things into your notebook. That is very important. And we will now move on to the next question. Let's see the next question. So students, now let's begin with some more examples. I have already taken the concept of implicit function. Now let's move on with some more examples. Now let's look at the first example that is written on the board. Y is equal to root of sin x plus root of sin x plus root of sin x plus root of sin x, and so on. It goes on continuing till infinity. Now it's a very important question. Lot of CTs and JWs will be having such kind of a question in the exam. So in place of sin, they might change with some other function. They might put up only x, they might put up tan x, they might put any other function, but usually the pattern remains same. So understand the pattern. So y is equal to root of sin x plus root of sin x plus root of sin x, and so on till infinity. Now it makes definitely a sense to you that you cannot keep on differentiating this for infinite time. Are you getting it? So there is first a root. You will write a derivative of root 1 upon 2 root. Then whatever is present inside the root, you will start differentiating it. So if you observe, there is a continuous line of functions till infinity. That means I will need to keep on differentiating it till infinity. That is absolutely absurd, isn't it? So you need to find a technique or a way to get the derivative of such kind of a function. So watch carefully. So I have y is equal to, there is root of sin x plus again root of sin x plus again root of sin x. I'll write one more time, plus root of sin x and plus dot 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 till it goes continuing up to infinity. Now observe carefully. See what I'm going to do here. I am going to for some time remove this root of y sin x from here. It has not gone anywhere. I'm just hiding it for some time. Let us understand, or let us observe that this root of sin x I have hidden for some time. So now your focus should not be on the blue part. Do not focus on the blue part. Just focus on the white part. Root of sin x plus 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 root of sin x, and so on. It will keep on coming up to what? Up to infinity. Are you getting it? Root of sin x. Watch only the white part. Root of sin x plus root of sin x plus root of sin x, and so on up to infinity. Only attention must be on the white part. Do not see the blue part there. Blue part is absent from there. Just focus on the white part. Root sin x, root sin x, root sin, and so on up to infinity. Isn't it y? Root sin x plus root sin x plus root sin x up to infinity is y. That means this entire thing can be called as y, isn't it? Entire function can be called as y. So this has become y is equal to, let's introduce that root sin x blue part again. So that's root of sin x plus y. So do you observe that x and y are both implied together inside the equation, inside the function? That's an implicit function. So what I do now, observe again, I'm going to do squaring on both end sides. Let's do squaring. As far as possible, if it is okay, if you are able to do it, only then you should be proceeding. If you are observing that y can be arranged and brought together, try to do it. Otherwise, even if you don't do it, does not matter at all. It will not matter, students. You just have to keep on differentiating all terms of y like they are x, and just add a dy by dx at the end of the term of y. That's all you should be doing. But as I said, to get a more simpler answer, to arrive at the result very quickly, what you should be doing is, as far as possible, try to get all the y's together. Try to get it. You might not get a single isolated y. That is not a requirement. I do not want a single isolated y. I just need all terms of y to be together. That's all I need. So what I do here is, I do squaring. I get y square is equal to sin x plus y. So you can bring y on the other hand side, or you can write like this, y square minus y minus sin x is equal to 0. So that's your equation where x and y have come together, and it is not very easy to express y as a function of x. So such kind of functions are called as implicit function. And now you will differentiate both sides as usual, differentiate both sides with respect to x as usual. Whatever term of x is there, you already know the derivative. Whatever term of y is there, you treat it like an x, just add a dy by dx at the end. That's all you should be doing. So what's the first term? That's y square. What will be its derivative? You treat it like x, so you read it as x square. So what is derivative of x square? It is 2x. So what could be derivative of y square? It will be 2y. So just write 2y, isn't it? Very simple, 2y. But since it's a term of y, what I will do here is I will write dy by dx. That's all you should be doing. Next term is minus of y, so it is like x for me, isn't it? So derivative of x is 1, so likewise derivative of y will also be 1, but since it's a term of y, I will write dy by dx. And finally I have minus sin x. It is a term of x, its derivative is very simple. You write minus cos x equal to 0. Whatever terms which contain dy by dx should be kept on one side. Whatever terms which do not have a dy by dx should be sent on the other hand side. So from these two terms I can take out the dy by dx common. Let's bring the dy by dx common. What is left inside the bracket with the first term? There is 2y. The second term will have minus 1. The minus cos x has been transferred on the other hand side, so let's write it cos x, isn't it? So I get from here my answer as dy by dx is equal to cos x upon 2y minus 1. So that is how you can get easily the answer or the derivative of the function which was continuing up to infinity. So I had y is equal to root sin x plus root sin x plus root sin x up to infinity, and the answer, if you observe, very simple, dy by dx equal to cos x upon 2y minus 1. Make sure you are simultaneously noting down the solutions as well. Whenever you think that you need to stop the video, write down the notes, make sure that you do it, because writing will only help you to grasp the concepts more properly. So make sure that you're writing down the solution. Let's move on to the next question. So students, now what I'm going to do here is I'm going to solve the third question for you, and the second question you should genuinely try, because whatever concept I'm going to teach you for the third question will be applicable for the second question as well. So make sure that you watch the solution for the third question very properly. Now what's the question that we have? We have x raised to y into y raised to x is equal to x plus y raised to, again you have x plus y. Now you must have definitely realized that it is difficult to express y as a function of x, isn't it? Expressing y in terms of x might not be always possible. Sometimes it is possible, but even then expressing y in terms of x can be sometimes very tedious, very uncomfortable. So we don't do always that thing, isn't it? So now here I can observe there is y present in the exponential. Did you observe that y is present in the power? It is present in the index. It is present in the power, isn't it? The index. So I can do what here? I can bring that y from the top, from the head to the bottom, isn't it? By applying logs on both the sides. So I'm going to take log on both sides. Now observe, this entire thing is your left hand side, and likewise this entire term will be called as the right hand side. So there is LHS and then there is RHS. When you take log on both sides, it means the log will be written for the entire term. For the entire term it will come. So the log is to be written for the entire term. So likewise here also you will put a bracket and then write log for the entire term. Now when you take log on both sides, what happens? Let's take log on both hand sides. So over here I can see log of something into something. So it's like log of a into b. Log of a into b, if you know, it is log a plus log b. So I can write here log of x raised to y plus log of y raised to x. Very simple it is, isn't it? Basic rules of logarithms. So if you are not aware of basic rules of logarithms, I have different videos on derivatives where in detail all these concepts have been taught. Make sure that you go and watch those videos also, like them, share them, and please do subscribe to my channel Pankaj Lade. Now, I have taken log a into b, it was log a plus log b. On the right hand side there is log of x plus y raised to x plus y. Now what I can do here is, we already know this one property, log of m raised to n. So don't you know what is log of m raised to n? It is n log m. So let's make use of that. So I have log of x raised to y, I can add y log x. Then there is x into log y, isn't it? And then there is this again, x plus y. X plus y is like m, and another x plus y is like n. So this is like log of m raised to n. So again n comes down. So I'll write here x plus y into log of x plus y. Now remember that this x plus y and this log of x plus y, these are two very separate terms from each other. X plus y and log of x plus y, very separate terms from each other. Now let's differentiate, isn't it? It's very simple. Let's differentiate. So I have y as it is, derivative of log x. So I guess you have observed that y into log x, y is not a constant, log of x is a term of x, so that's u into v rule. So first term as it is, derivative of log x, it is going to be 1 upon x plus log x as it is, isn't it? Log x as it is, derivative of y is going to be 1, but since it's a term of y, let's write dy by dx, isn't it? So always and always make sure that you keep this in mind, that all terms of y will be treated like x, but you should just write dy by dx at the end, isn't it? So always remember to add that dy by dx ahead of the term. Let's move ahead. So there is again a plus sign, again x into log y. X, obviously you can understand it's a function of x. Log y, not a constant, again it contains x, again u into v rule. X as it is, derivative of log y, you are treating y like x, that means you are actually reading log y as log x. What is derivative of log x? 1 upon x. What will be derivative of log y? 1 upon y, but since it is a term of y, you will write dy by dx. Now that was first term as it is, derivative of second term. Then let us write plus sign, second term as it is, that is log y as it is, derivative of x, that's 1. So all derivative of left hand side is over. Now let's move on to the right side. So right side we have x plus y into log of x plus y. So first x plus y as it is, x plus y as it is, derivative of log derivative of log. Do not worry whatever is present ahead of it. Just make sure that it contains something in x. Something in x must be present. So ahead of log, I can see something present in x. So that's log of x only, isn't it? So what is derivative of log x? It is 1 upon x. So what could be derivative of log of x plus y? It will be 1 upon x plus y. But it is not x. It is something in x. So that something in x should again be differentiated with respect to x. So again put a bracket. So we have x plus y. Let's differentiate it. So derivative of x is 1, isn't it? Derivative of x is 1 and the derivative of y is going to be dy by dx. Did you understand that? So x plus y, the derivative of x is 1, derivative of y is also 1, but since it's a term of y, I have written dy by dx. So that was x plus y as it is, derivative of log of x plus y. Put a plus sign because again you are using u into v rule. I hope you must have definitely observed that, isn't it? U into v rule. So first term as it is, derivative of second term as it is, so log of x plus y as it is into derivative of the first term, which is x plus y. So what could be x plus y derivative? Think like this, there is a d by dx and then you are writing x plus y ahead of it. So d by dx and then there is x plus y. So the first term is x, derivative of x is 1 and derivative of y is dy by dx. Now Next job is to collect all terms of dy by dx together. Before that, I can observe this x plus y can be cancelled. So let's get rid of that x plus y, isn't it? Now there are two terms of dy by dx on the left. There are two terms of dy by dx on the left. That's one of the term dy by dx, and then there is one more term of dy by dx here, isn't it? So there are two terms of dy by dx. I have to get them together. So let's get this two terms of dy by dx together. So over here I can now write the terms like this. So there is y upon x. So let's write y upon x. Let's write y upon x, the first term, isn't it? It does not contain dy by dx. There is y upon x. Then there is plus log y. It also does not contain dy by dx. All the terms which does not contain dy by dx has been taken together, has been collected together. Are you getting it? We have collected all terms which did not have dy by dx together. Whichever terms have dy by dx, I'm going to get them together. So let's take these two terms together. Let us write a plus sign, isn't it? And then you take out the dy by dx common. You will be left with log x plus x upon y, put it in a bracket, and what have you taken out common? The dy by dx is taken out common. So that was from the two terms which have been circled with a yellow chalk, isn't it? With a yellow color. Now let's come on the right hand side. So there is 1 plus dy by dx, then again log of x plus y, 1 plus dy by dx. You can definitely take out 1 plus dy by dx common. So now if you observe the right hand side, there is 1 plus dy by dx plus log of x plus y and 1 plus dy by dx. Now what you can do here is you can directly take out 1 plus dy by dx outside, but that won't help you because you have to collect all terms of dy by dx together, isn't it? So I'm going to write it like this: 1 plus dy by dx, and then again plus, let's multiply log of x plus y inside the bracket. So you get log of x plus y into 1, so that's log of x plus y, and then plus log of x plus y into dy by dx. So how many terms of dy by dx can you get from here? So there is this dy by dx here, there is one more dy by dx over here, and this one more term of dy by dx. So I'm going to get all these terms of dy by dx together. So let's get all the terms of dy by dx together, and all terms which do not have a dy by dx should be collected together. So I'll be writing like this. So this first term, second term, third term, they are all taken together. Now I'm going to take a shortcut over here. These two terms when transferred on the left hand side will become negative. They will change their signs, and you are taking out dy by dx common, so you will be left with log x plus x upon y. Then this term has transferred on the other hand side, so that's minus 1 and minus of log of x plus y. And what are you going to take out common from here? It is dy by dx. That is equal to, on the right hand side again there is 1, then there is log of x plus y. So 1 plus log of x plus y. These two terms have come together, and these two terms y upon x and log y, they were on the left hand side, did not have dy by dx, will be transferred on the other hand side. So I write minus y upon x minus log of y. So there is a less space available now. I hope so far you have understood what I have written, isn't it? So far the steps are very clear to all of you. Now what finally you need to do is you need to get the answer of dy by dx. So this entire bracket must be transferred on the right hand side. It is in multiplication over here. When it moves on the right hand side, it will become division. So it will come in the denominator over here, isn't it? So you get dy by dx equal to, you have something over here, isn't it? This is the right hand side, and the left hand side comes into the denominator. I hope you will be able to manage the last step. So students, this was the problem x raised to y, y raised to x equal to x plus y raised to x plus y. The same steps, taking log on both end sides and then arranging the terms and then differentiating, should be done in the second question as well. So I hope you will be definitely doing the second question on your own. So this was the solution for the third one, isn't it? Make sure that you are writing it down very properly, very thoroughly into your notebooks. Let us now move on to the next question. Students, now let's move on to the last question of this particular concept. Make sure that you understand the last question also very properly, and then start solving as many questions as you can. And if you get anything that you are not able to solve, mention those questions into the comment box. I will definitely get back with the solution with a proper explanation. Now let's move on to the last question. As I said, we have cos inverse of, there is x square minus y square, x square plus y square inside the bracket, then there is tan inverse of a on the right hand side. Now you got to start analyzing the question very properly. If you observe the right hand side, there is a. Is your mind telling you that a is a constant? A is a constant. Are you getting it? There are only two variables involved in the question. There is x and then there is y. A is a constant term. Now if you observe that a is a constant term, you should also know that tan inverse of a is also a constant. That means I can say that tan inverse of a is a constant. Is it okay if I call it as a new constant? Let's name it as k. It's a constant, isn't it? A is a constant. So tan inverse of a, whatever number you take a, let's take 1. So if I take tan inverse of 1, you know that tan inverse of 1 is pi by 4, isn't it? So that's a constant term. So over here I can say that tan inverse of is a constant. Let's call it as k. Let's transfer cos inverse on the other hand side. Let's do it. Let's see what happens. So I get x square minus y square upon x square plus y square is equal to. So when I transfer cos inverse on the other hand side, it will become cos. So that's cos of k, isn't it? Where k was tan inverse of a. But if k is a constant, what is cos k? Also a constant, isn't it? It's constant again. So is it okay if I call it as m? Isn't it? It's a constant. So let's write it m over here. That's m. Now what you do is, let's transfer. As I said, as far as possible, start collecting all terms of x on one side, start collecting all terms of y on one side. Collection of all x's on one side, collection of all y's on the other side. As far as possible. It's not compulsorily you have to do it, but if it is possible, try to do it. So now let's transfer on the other hand side. I get x square minus y square is equal to, so x square plus y square is transferred on the other hand side. You get m into x square plus m into y square. Are you getting that? Now there are two terms of x square and two terms of y square. Let's get them together. So there is one m into x square here on the right hand side. Let us bring it on the left hand side, and then we have this y square. You transfer it on the other hand side. So now what I can do here is, when it's transferred on the left hand side, now you can observe that both the terms will contain x square. It can be taken out common. So I can get 1 minus m and x square, and when this terms goes on the other hand side, it becomes plus y square. So there is m plus 1, or I add 1 plus m, and then there is y square. Now again, some kind of arrangement can be still possible. 1 plus m is a constant term. I can write it like this: y square is equal to 1 plus m, sorry, 1 minus m upon 1 plus m into x square. Now do you know that m was a constant? See, m was a constant, isn't it? If m is a constant, what can you tell me about 1 minus m, 1 plus m? 1 minus m upon 1 plus m. When a constant gets added or subtracted or multiplied or divided by another constant, the new result is also a constant. So this is a constant, can be called as new constant, let's say b. So y, or you can say just c into x square. Y square is equal to some constant c into x square. See, very simple it is, isn't it? Y square is equal to c into x square. Now you simply differentiate both end sides with respect to x. Let's differentiate both sides with respect to x. So what is derivative of y square? It is like x square for us, isn't it? Y square is like x square. Derivative of x square is 2x. So derivative of y square is also 2y, and you write dy by dx. Then c is a constant term, isn't it? You are thinking about dy dx on this side also. C comes constant, comes outside the derivative. Then the derivative of x square, it is 2x, very simply written. This 2 and 2 will get cancelled from both the sides. So from here you get dy by dx is equal to c x upon y. Are you getting that part or not? So dy by dx is equal to c into x upon y. Now observe this is very important. Look at this equation. This is very important stuff, people. Try and understand. Did you notice what the question was given to us? Have you seen what the question is given? He is expecting me to get dy by dx. He wants me to get dy by dx, and the answer should come y upon x. The answer of dy by dx should come y upon x. It has not come so far. It has not come so far. So I have to do something, isn't it? So I go back to this equation. Let's call it as equation 1. I'm going to rearrange equation 1. Let's see the rearrangement. So we have y square is equal to c into x square. So I write c is equal to y square upon x square from equation 1, isn't it? C can be written as y square upon x square. X square is multiplied over here. So c comes y square upon x square. So I'll be writing c as y square upon x square, isn't it, into x upon y. So let's cancel the common terms. Y and y gets cancelled. X and x also gets cancelled. Your answer comes how much? It is y upon x. Is that the answer that has been expected in the question? Dy by dx should be y upon x. So students, I guess you have properly understood what an implicit function is. I have taken some questions on implicit functions. Make sure that you take your textbook and solve as many questions on implicit functions as you can, and whatever things, if there is anything that you are not able to understand, please get back to us. I will definitely make every single effort to solve the query of yours. So I thank you all for watching this video. Make sure that you are liking all the videos, you are sharing them with your friends, and please do subscribe to my channel and let me know in the comment box what topic you would like to learn from me. I will definitely make a video on that particular concept as well. So thank you one more time for watching this video. You all have a great day ahead. Thank you so much.